Hey everybody, we had previously built our first project using the TTGO T-Display, measuring temperature and humidity, being able to convert between Fahrenheit and Celsius, as well as heat index. And I said that we would build upon this project, and we're going to do so now. The limitation of this device is you have to be standing in front of it in order to be able to use it. So we're going to make it so you can use this device over the network, having the same functionality from the web browser of a smartphone or computer. Now, I had done a separate series about converting Arduino IDE projects to platform I/O using this project as an example. However, since we started this project in Arduino IDE, I'm going to be continuing this project in Arduino IDE. So the first thing we're going to do is include the Wi-Fi and the web server libraries into our project. Once we've done that, we're going to make an instance of the Wi-Fi client. We're going to call it ESP client. And an instance of the web server. We're going to call it server. It's going to be on port 80. It's going to be unencrypted. Our Wi-Fi is going to need some parameters, such as an SSID, as well as a password. Now, there are ways we could have a whole system of being able to provide SSID and password through connecting via Bluetooth or providing an unencrypted access point directly into the device to be able to add this information. It's very complex. For this one, we're going to be hard coding these values directly into the file. We can make an entire video just about supplying SSID and passwords into devices. We're not going to be doing that for this one. We're going to take the easier road right here. That's for an entirely separate project. As we make our way down to setup, we're going to have to add some things in support of Wi-Fi. We set the Wi-Fi mode to connect to an access point, our router. We connect with the SSID and password that we just provided before. And we provide a loop to allow for some time for it to be able to connect. Prints a little dot to the serial output, dot after dot after dot, until such time as it connects. We're going to provide that logic for once it connects just below. We can see that once it connects, it'll say Wi-Fi connected, IP address is, and then it'll pull the IP address that it pulled via DHCP from the router and display it in serial so you know what the IP address of this device is going to be. We still have to set up the minimum setup required for this web server. Obviously, we're just going to be doing like a hello world at this point, like I had mentioned, so we're going to set up for that. And we're saying that when it hits that top level of the domain, what to do, and we're going to call a function called handle root, a function to be written, but we'll come back to that. And that's all we're doing right now. So we'll say server begin. The last thing that we have to do with regard to that is in loop. We're going to want to come around and see if clients need to be handled. So the only thing that's left to do is provide the code to handle root on the server when we reach that point right here, the root. So let's do that now. So here we have a function, handle root. It's void. I want to create, and like I said, very simple what we're doing here for this first go around. I'm just going to create simple hello world. Web server happens to use string data type. So I put together very simple HTML string. We could see within the string, HTML head, title. I put together a little title, close head, open body. The body is hello world web page, close body, close HTML, and that is the bare minimum, if you would, for a hello world HTML page. So now all we have to do is direct the server to send with 200, tell it that it is text HTML, what to send, the value of S, which is that string. And that's it. That is the bare minimum to have a running web server. So when we go on one of our devices to the IP address that will be assigned, we're going to find out what it is through the serial terminal. Like I said, very rudimentary. We should be able to see a web page come up with this information while the device is still running its normal code that it was running before for the application. Let's see what happens. So I pushed the resulting code to the device, and we're going to restart the device now. We could see that it's got an IP address here, 192.168.1.109. Given that there's only one dot here, it didn't take that long to connect to the router. If it took longer, there'd be a couple of dots before that connection. Now that we have an IP address, we could go to a web browser. We'll put that IP address in. We'll see what happens. Here we have the IP address already in the browser. So we'll hit enter. And then we have our simple web page. The title, hello world. and hello world web page. So we've already accomplished our first goal. Let's see what we could build upon this. With that working, there's a couple changes I'd like to immediately make. There are many ways that we could store HTML on the ESP32. I think that the simplest way, and a way that beginners could understand, is to simply store it in the way that I'm demonstrating now and call it within the same program and not have to use separate files in spiffs. So I'm going to demonstrate it in this manner. So now I've changed that up. So any HTML that we're going to do, we can now do in this area. Another thing I'd like to do is we're going to add MDNS support so we don't have to use the IP address to load the web page. We're going to include the MDNS library, and then in setup, just at the moment Wi-Fi connects, we'll create a if statement that'll throw an error if MDNS doesn't start. The argument for this is going to be the name that we're going to use. So it's going to be ESP32.local will actually be what we put in the web browser, or what we hope to put in the web browser to load our web page. But we're doing so as a condition to throw an error. So we might as well have an error go into the terminal if it doesn't start, and then just drop out. So there we go. If Wi-Fi is connected, if DNS starts, then we can post a serial saying what the IP address is. We won't really need the IP address to go to the web page. We could just go to ESP32.local from our web browser to hit it. Let's try it out. So now we'll go to the URL ESP32.local. And we can see it took us to the web page. We can still use the IP address if we choose. Also take us there. I want to make a couple more changes to network connectivity before we continue. I see a couple of gaps here I want to address. First of all, I want to declare an actual device name as a value, and we're going to call it ESP32DHT. I dropped the 22. We're not going to use it in this example. And the reason why I'm doing this is twofold. Number one, we're going to use that value here in this argument when we begin MDNS. And the second reason is this. Right after we have network connectivity, I want to create a new screen that appears on the display. We're going to leverage the display to do this, and we're going to have to reorder a couple things, shuffle some things around to do that. So what we're going to shuffle around is we're going to move these begin statements and the rotation up here to support this. Basically what will happen is when the device turns on, we connect to the network, there'll be a new screen that appears for a certain amount of time to say, hey, this is the IP address and this is how you connect to it via web browser. This is called by a function called show screen network. So here we have show screen network. Basically I've done it in the same fashion as the other screens. Make the screen black, text color orange. We'll see the word IP. On the next line, we'll show the IP address. A couple lines down, in a smaller font, we'll actually show HTTP, the name of the device, .local, and we'll delay this for 5 seconds so the user can view it before running back to the regular course of the program. We can see it breaks out right here, and then continues on exactly as it did before. Let's try this out, see what happens. So you can see we got an IP address, and it is displaying the information to the screen along with the URL, and now the normal functions of the device have started up. See, it's working fine. Fahrenheit to Celsius, or heat index, or what have you. And now we'll go to a web browser, and we can see the page is loaded. I'm just going to hit refresh, and I refreshed it, and we can see ESP32DHT.local loaded just fine. So everything's working nice, but now we have that extra added value of being able to see how we connect to it over a web browser or IP address. I want to talk about something that some of you may have noticed. The way the program is as written. Now, in order for this program to function, in order for this device to work, it is dependent upon wireless access, because we could see here during setup, we are caught in this loop. It is going to keep drawing this period over and over again until we have network access. And if you are not connected to your router, if that wireless password or SSID is wrong, we're never going to see anything come up on that screen. It's always going to be black. Of course, this is not a very effective way to roll something out. The wireless should be a feature. It shouldn't be dependent upon wireless, but we're trying to keep this program simple. So I wanted to point that out. If you see a screen is blank, when this program runs, check your SSID and password. It's probably wrong. In preparation for sending data to the web page, we're going to have to make a change, and what we want to do is we're going to create 3 global variables to replace some of the locally scoped variables. And I'm calling it temp, heat index, and humidity, 3 floats. And I'm going to show you how we had applied them locally in screen 1 and screen 2 and some other changes that we made along the way. I left the old ones in, commented out so we could see. They weren't well named earlier. They were just T for temperature, H for humidity, and HI for heat index. So I renamed them something easier to read. So instead of declaring them locally within the function, float T is just temp. You don't have to write float because it's already been declared. So temp equals get the temperature, humidity right here as shown, and heat index like this. You'll also notice that on screen 1, where we do not get the heat index, we are actually saying to update the heat index, update that global value, even though we would generally, or in our older program, only pull the heat index when we were on screen 2, which is the heat index screen. I'm going to explain why in just a little bit, but note that regardless of the screen, we want to pull all the values: temperature, humidity, heat index, and a fourth one that we get as a freebie is if we are using Fahrenheit or not. So basically, these 4 values need to be populated at each update interval so we can pass these values to the web page. We're going to start populating our web page with the data that's coming out of the sensor. But before we do, I found a slight shortfall that I wanted to address. We were using the use Fahrenheit. This value is changing from the press of a button. What we need is the moment the data is sent to these values. So I've created a new bool called as Fahrenheit. And as Fahrenheit is copied from use Fahrenheit the moment that these are populated, because there can be up to 1 second delay. And I'll just talk about that for just a moment. So we could see that as these values are populated, as Fahrenheit equals use Fahrenheit the very moment that these are used as parameters. So this is more accurate. This will be more stable. And that's what we're going with for that. I wanted to clear that up right quick. And what we're going to do here is we have this web page. The body is empty right now. And what we care about right now is just data. We just want to see the data. We're not trying to build our final web page. We have to work in steps. So I'm going to create an entry here for 4 values that I've prepared already with IDs that can be referenced. And I'm going to put them here. And there are 4: temperature, humidity, heat index, and is Fahrenheit. And I've named them individually so they can be referenced right here. And then I've just put like a default values just so we could see that there's not a blank space right after the names. These should be updated the first time that we have a request go back to populate these values. It's not fancy, but it's going to do the job to make sure we're getting the data that we want. And we're going to have to start some JavaScript here to ensure that these get updated at regular intervals. So we'll open that up now. And we're just going to open up our script, and we're going to say that we're going to call a function, and we're going to call that function getData every second. So every second we're going to run that function. And here's our script called getData. It's going to be run every second, and this request is going to go out, and it's going to wait to do this. Once it gets back the information with a status of 200, it's going to populate those fields that we just created up here with the values that it receives from the JSON that's parsed when it comes back. We'll discuss that in a moment. Basically what it's going to say is go out and get this request, and when the values come back, populate and update these fields every second. How is it going to do that? It's going to do that by doing a get request called read data. Very simple. Since that's all we're doing in JavaScript, we close out our script, close out our body, HTML, we're done. We're going to run it this far just to see what we get. And we could see it came up with everything that we wrote in HTML plus those default values that I added in. And we're going to look at the developer tools for this right now. If we look at what's running in the background, every second, we can see the get request error is incrementing because there's actually not a service on the ESP32 for read data. We haven't written it. So I've written the handle data function called upon by read data, and this works just fine. I wasn't going to build any fancy routine to build this JSON string that only has 1, 2, 3, 4 values in it. You can see that I built it out like so, just structuring it so it would actually be valid JSON, push it through. I've also printed it to the serial terminal. And while we're going to see that this works on the web browser, it doesn't really work perfectly. There are problems with this. notably the web server library itself, and I'll show you what I ran into. One of the main problems here is a function of server, which is handle client, needs to run in loop constantly. So it's always polling handle client for requests. And we have within loop to control how often we hit the hardware, a 2-second delay. Having this here in 2 seconds was causing this to pause, and we weren't getting the request back that we needed. So in order to find the best way to handle this, I had to offload it onto the other processor as a separate task. And that worked to a degree. The problem is the web server that comes with Arduino IDE. Most folks know I don't use Arduino IDE for development. I use it for this example. I have a different web server that I use in Platform IO, and I was hoping that this web server would work for asynchronous requests. It didn't really fit the bill. It works okay for an example. I don't think it's something we're going to go with. Let me show you what happens. So here we have everything up and running right now. We can see that it's a little bit skewed between Firefox in the background and Chrome in the foreground. Depends on when they started their counter, and that's just fine. If I go to the device and change from Fahrenheit to Celsius and click the button, we can see is Fahrenheit changed, and now it's Celsius. We can see the values are Celsius now as a result of that, to include also the heat index. Everything appears to be working. We could see these error connection resets that are here, and as this sits, and also as I add more computers to this URL to poll, this starts to increase, and quickly. Sometimes you get a burst of like 50 or so, and it'll just stop getting these values updated, and this has become a problem. And I tried this out with Platform IO with my other web server, the ESP async web server, and there's no problem at all. So I did what I could to see if we could use this web server, and it's probably not going to be viable. And there could be some other problems that extend beyond this, or issues for instability for the device or program. So we're going to have to move off this web server and onto the other web server. We're going to download this library first. Link will be provided in the comments below. From this page, async TCP, click on code. Then we're going to download the zip file, async tcp-master.zip. Then we're going to go to this page, ESP async web server, link also provided below. From this page, we're also going to go to code, download zip file, again save ESP async web server-master.zip. I moved it into a temporary folder so it'll be easier to work with. I'm going to open up each one of these files now. This results in the creation of 2 directories. I'm going to rename these directories. I'm going to remove the -master from these. Now I'm going to open up another folder, and we can see my Arduino libraries folder in my documents directory. And here we have all of the libraries that are installed by our library manager, and we're going to manually move these 2 folders directly into that directory. Once these folders are dropped in, you're going to close out from Arduino IDE and then restart it. With the new web server installed, I could show the changes that have been implemented. It's easier to start at the bottom. The loop hasn't changed. It's the loop between the 2 screens. I had that task that was pushed off to the second processor in support of the web server, and that's no longer needed. But instead, I'm now using that to detect the push buttons. There's a lot of problems that I had found with the interrupts with this particular TTGO T-Display. I discovered this after porting the project to Platform IO, and turns out there are some hardware issues, and I think they do manifest themselves to some degree in Arduino IDE. So I thought it better to take advantage of it and simply remove it from an interrupt and just have a function on that second processor that checks to see if the button's been pressed, and then if it has been pressed, it moves it off to toggle button 1 and toggle button 2 as a function. As I move up, we see that setup hasn't changed a whole lot. So we have server on handle root, and the server on read data is over here. I've added on both screens to check if it's not a number to return without updating the values so we don't get NANs. Sometimes it does misfire because it's very slow. So that's an improvement I just threw in there. Local variables were created again. Then those local variables are copied to our global variables. Same procedure up here for the first screen. The toggle buttons are now regular functions. It uses the same debounce. The procedures inside have not changed at all. The web server requests are identical inside, except for some of the syntax and the arguments for the functions. And of course, the includes have changed: async TCP and ESP async web server. And now we call an instance of async web server on port 80. So these are all the changes that have been put in place, but the output is identical. As far as the web page goes, some changes have been made. We now have a radio button group for Celsius and Fahrenheit. It's defaulted to Celsius. One of the reasons I did it this way with the is Fahrenheit, you probably realize by now that anytime somebody presses the button on the device, it changes the value that's sent to the web page. This is sort of an exercise in offloading some of the tasks onto the web browser. So getting that is Fahrenheit value lets the JavaScript application within the web browser know that the values that it's getting is Fahrenheit, allowing it to convert those values if necessary based on the status of the radio button. I'll demonstrate. If we follow the logic here, if the value that came in is Fahrenheit and the radio button is Fahrenheit, there's no condition for conversion. It just comes straight through out the bottom. If the value of is Fahrenheit is 0, so it's Celsius, it would fall into this else statement. And if it was Celsius that was selected in the radio button, there would be no processing, so it would fall out to the bottom here. It's only when it meets those exceptions that it's made to convert the temp value. When it converts the temp value to keep it exactly as it was without conversion, I'm limiting it to the 100th, and that's what the toFixed does after the conversion. So ideally what we should see is, regardless of the button depressed on the actual device, everything should always look the same on the web browser, even though the web browser is converting those values live from Celsius to Fahrenheit based on the conversion of the radio button. So they seem to function seemingly independent from each other, even though they're tightly woven together. It seems a bit Rube Goldberg, but it is a nice exercise. Clearly, I could have done all this on the device and only sent a Celsius value and then let the radio button value convert it based on that selection. I just chose not to because I thought this would be fun. Furthermore, on these values, based on Fahrenheit or Celsius, I append an F or a C, and on humidity, I append a percentage sign to the resulting values that's displayed on the web page. Let's try it out and see how it works. You can see the device is up and running. The temperature matches, the humidity matches. Both of them are set for Fahrenheit right now. I could set the browser for Celsius. I'll move the device over to Celsius. Fahrenheit, Celsius, back and forth. We could watch the is Fahrenheit value. That value will change, but the values in the web app don't move because they're constantly being readjusted based on that is Fahrenheit value. We're going to finish up this project now by adding in a little bit of CSS to spruce things up. It's all going to be based around tables, which we're going to drop everything into. That done, a table's created with the title. We put all of our content in there, and then we put all the values in there. I put a little footer on the bottom, and that closes everything up. Let's take a look and see what it looks like now. We can see how everything is now laid out in the table. Looks very nice. Switch to Fahrenheit. Everything switches nicely. Switch to Celsius. Functionality same as before. It's just presented better. I have a link that opens to a new window. So that's set up well too. Also, again, functionality of the device is not lost. There's Celsius. One last quick addition. Sometimes the Wi-Fi fails to start when this thing reboots. I added in a loop that after 15 tries, the ESP32 should simply restart. Generally on the second time the Wi-Fi picks up, but instead of the screen just sitting there dark and the thing never turning on, this should rectify that problem. And with that, we have finished the second project for the TTGO T-Display, our second ESP32 project. I hope you enjoyed this video. Do me a favor, click that like button down below. Helps me out a lot when you do. And click that subscribe button for more videos. Again, I hope you enjoyed this video. Thanks for watching.
Thanks for watching. Would you like to reply?